Hello, everyone. My name is Akinbile Demilade, and I'm a PhD student at Kansas State in biological and agricultural engineering. And today I'll be presenting the result of my internship this summer, working with WEBCO Manufacturing Incorporated at Oleta under Pollution and Prevention Institute of Kansas State University. So, uh, the background about the company was founded in 1980 and specialized in industrial manufacturing parts. So WEBCO is original equipment manufacturer of metal parts for aviation, construction, industrial cooling, mining, railway maintenance, and trucking. And the capability of WEBCO include robotic welding, laser and plasma coating, as well as liquid and powder coating. So WEBCO had an intern from Pollution Prevention Institute in 2016. That was the last time they had it before. I actually privileged to be an intern this year. So here is a WEBCO floor plan. So the floor plan of the WEBCO is oriented in the direction of the raw material to the final product. So the raw material, which is mainly carbon steel, is used to produce the metal parts. And the raw material is delivered in large sheets on the western side of the plant. So the metal is then passed through a laser and plasma cutting machine. So, and in the final phase, the product is moved through the fabrication, the welding, and the painting section to deliver quality finished products. So my final projects include various ways of savings of energy, cost, and reduction of air toxic emission. So I look into the leak audit of the compressed gases, optimization of overspray powder paint recycling, reduction of volatile organic compound, and hazardous air pollutant in the industrial process, and evaluation of the previous pollution prevention intern implemented projects. Now let's go to the project. So I work on on 4 different projects, and the other 2 projects are the review of the former intern recommendation. So the first project is actually the compressed gas audit. So, and the compressed gases used in WEBCO facilities include the compressed air, nitrogen, oxygen, and the welding gas, which include the argon and the carbon dioxide. So as we all know that compressed gas is not free, and its leakage is a big financial burden on the company. So the leakages of compressed gas could be on notice for a very long period of time if the leak audit is not conducted periodically. So I conducted the leak audit with Ultra Probe 9000 leak detector on all the compressed gases pipelines in the WEBCO facility. So the audit was conducted in 2 different distinct areas. The first audit was in the weld area, and the second audit was done in the other area of the facility. So most of the leak I find are the joints of the connection, and they are either loose or damaged in some ways. So on the leak was identified, the picture was taken, as you can see on the left-hand side of this, on the right-hand side of this slide, and it is being marked as being inspected. So, and the reading was stored in the leak survey app, which was used to calculate the leak, cost avoidance, the size of the leak, and the energy avoidance. So in total, 33 leaks were discovered. So, and the compressed air leaks actually accounted for the 92% of the compressed gas loss, but represent just only 37% of the saving opportunity. On the other hand, the mixture of the welding gas, which is an argon and CO2, represent 3% of the leakages, but actually accounted for 25% of the leak cost avoidance. So by fixing the leak around the operating area, about 27,200 potential cost savings could be realized, and 89,900 kilowatt hour of energy savings per annum, and 312 metric ton of CO2 equivalent could be avoided. So, and actually in my final recommendation, I recommend that the routine ultrasonic leak detection survey every year, as the most compressed gas can be easily identified. Now to the second project. The second project is excess powder paint recycling upgrade system. So the WEBCO only recycle two types of powder paint, so the cast yellow and the cascade black powder. So I examined the existing recycling system, and I had a meeting with the equipment supplier to know about different options. The efficiency of the existing recycling system is about 50%. So I obtained all the purchase order of the annual usages of the powder paints and the price list. So my calculations shows that only about 3,000 pounds of powder paint are recycled every year. So the new recycling system will include a control panel for pneumatic regulated air control of the powder reclaim, transfer, and fresh powder transfer, as well as the indicator light when the reclaimed powder level is low. So in order to make it easy for the color change to any collector system, so I recommend 2 color change accessories. So the total amount of powder paint recycling upgrade system is about $54,000, and the powder paint recycling system upgrade will result in a cost saving of $47,000 per annum, and the avoidance of more than 9,000 pounds of powder paint wastage. So, and the payback period is 13 months. So, and the good thing is the powder paint has no solvent. It emits no air hazardous pollutant, and it reduces the need to buy the costly pollution control equipment. And this will allow the WEBCO to economically comply with the regulation of Kansas Department of Health and Environment. So in addition to this, I also work on the evaluation of the powder paint volatile organic compound content. So the environmental data sheet and the safety data sheet show that the powder paint contains no volatile organic compound. So a letter was written to Kansas Department of Health and Environment to seek for the powder paint daily recording requirement of volatile organic compound. So all the information and the documents were gathered and submitted to the KDHE by creating special requests for WEBCO, and this is pending the final approval. So the third project actually has to do with the third project actually has to do with electrostatic spray gun. So and I examined the pollution prevention and cost saving of replacing the high volume, low pressure paint gun, which is being presently used in WEBCO, with electrostatic spray gun. So WEBCO intends to expand its liquid paint facility as there is new business opportunity. So all the paint guns used in WEBCO, as I said earlier, are high volume, low pressure paint gun with transfer efficiencies of 60%, according to the manufacturer specification. So at the rate of 60% transfer efficiency, about 220 gallons of liquid paint and 10,000 pounds are lost every year. So I recommend the Pro XP85AA electrostatic gun with transfer efficiency of 85%. So the higher efficiencies equal less waste, saving the money on the material, and reduction of volatile organic compound and air and hazardous air pollutant emission. So I recommend WEBCO to buy 2 electrostatic spray gun, which costs about $14,500. The electrostatic gun will reduce the emission in the facility by 0.2 tons per year of hazardous air pollutants and 0.6 tons per year of volatile organic compound. So the usage of this electrostatic gun will result in the cost saving of more than 6,700 pounds per annum and avoidance of more than 170 gallons of liquid paint and wastage. So the payback period is calculated as 26 months, and this project is fully recommended for implementation. Now, to the third, to the fourth project that I worked on. So the fourth project actually has to do with toxic air emission reduction. So as I said earlier, that the company has a new business opportunity for significant expansion that will result in the expanding both the size and the amount of the liquid paints. So the evaluation of the expansion actually examine the potential pollution prevention methods and the opportunity to mitigate or prevent an increase in their production and in their pollution footprint. So I completed the baseline monitoring and compliance reporting for the WEBCO air emission for the expansion of the liquid paint facility permits. So this process actually entails the comprehensive evaluation of the safety data sheets and the purchasing order of the liquid paint and the weld wires. So I prepared the toxic organic management plan, including the spill prevention, containment, and clean-up plan. So replacement of solvent-based liquid paint with water-based liquid, and the VTech wash thinner with acetone was actually recommended. So, and the water-based paint and the acetone will reduce the emission at the facility by 1 ton per year of hazardous air pollutants and 1.8 tons per year of volatile organic compound using the existing liquid paint quantity. And this will ease the burden under the KDHE VOC rules. Now, the fifth project actually has to do with evaluation of a project recommended by the former intern. So the former intern recommended the change of the lighting in the production area. So the energy saving project replaced the T5 fluorescent that was used before in the production area. So the lighting involved in installation of about 375 electronics 220 watt lumen LED in the production area, and which is completed in May 2020. So I evaluated the environmental impact and the cost saving of this project. So the implementation of the project resulted in 39% reduction in the lighting consumption, savings approximately more than 2,070 kilowatt hours per annum, and the saving cost of more than 27,800 per annum, and a yearly reduction of 312 metric tons of CO2 equivalent, with a payback period of less than 4 years. Now, the final project, what is the sixth project? This also is evaluation of the implemented projects recommended by the former intern. So the former intern examined the defined potential to improve the airflow during the summer month and the heating efficiencies during the winter. So he recommended installation of HVLS to improve the air circulation and the stratification due to the less heat in the working zone, and a better air quality in the productions area. The intern evaluated and estimated the environmental impact and cost savings of the project. So I evaluated this project and I found out that the implementation of the project resulted in 11,622 terms saved, an average cost savings of $4,000 per annum. So in summary, the combined effect of the 6 projects total a reduction of 3.6 tons of air toxic emission and 360,000 kilowatts hours electricity and more than 9,000 pounds of powder paint, 179 gallons of liquid paint, and 11,000 tons of natural gas. So the total estimate saving for this combined project is more than $118,000. So using the Environmental Protection Agency greenhouse gas calculation tools, this project's total annual reduction of about 785 metric tons carbon dioxide equivalent. So thank you everybody for listening to my presentation, and time for question and answer.